So welcome to Test-Driven Development in Vue with Cypress. I am Josh Justice, and a little overview for you to make sure that this is the talk that you're expecting or that you're hoping for or looking for is going to be theoretical and practical. So on the theoretical side, we're going to be talking about what test-driven development is and why you might want to reach for it, what the differences are between test-driven development and other kind of testing approaches. And then on the practical side, we're going to walk through actually test driving a simple feature in Vue using Cypress that's included with Vue CLI 3. So we're going to hit both sides of that. So I'm Josh. I go by Coding It Wrong on Twitter, and you can step through the presentation here and decide for yourself if I'm coding it wrong. I do a fair amount of speaking and writing and live streaming now. It's a new thing for me. And the reason, when I thought about what's my motivation, this phrase kind of captured it for me. I want to help developers build great apps and go home. Because I've spent too much time in my life under just pressure to work long hours and just go on and on. And I have a very fragile constitution, so I can't handle it. If you want to work 20 hours a day, then that's great. But maybe you should have the option to do it and do it on side projects if you want, or a startup if you want, and not feel the pressure from most employers on that. And so any processes, any techniques, any tools that help me to build great software and then go home to the rest of my life, I'm a big fan of. For me, some things that have really helped are agile practices like test-driven development, refactoring, evolutionary design. And so those are things that I like to talk about, and we're going to hit on a lot of those topics today. I work at Big Nerd Ranch, so we're a consultancy. We do native mobile development as well as web development, and we do trainings and we write books. And so we are actually hiring for Vue and other JavaScript developers right now. We are doing a project for a really big tech client that you've all heard of that I'm not going to tell you the name of them, doing a lot of vue.js work, and it's really fun. And so if you are in the market, we'd love to talk to you. We also have internships for winter and summer internships if you're kind of on the newer end. Those are paid internships. So check out bignerdranch.com/careers if you're interested in any of those. And I'm going to have a link at the end of the slides that has references to all the links and books that I recommend and things like that. So don't feel the need to write down all of the URLs as we go through the presentation. I have stickers, of course, that's very important. I've set a bunch of them out right in front of the podium here, or you can find me later for them. So Cypress, people do ask me sometimes if I work for Cypress. I don't, but I could, given how much of a fan I am of that testing tool. Big Nerd Ranch, Babel, we all love Babel, and then Atlanta Ember, actually. So if you also like Ember, or if you just like hamsters, you could pick up some of those stickers. So JavaScript testing, let's talk about JavaScript testing in general. I feel like JavaScript testing has really gotten big in the last couple of years. There's a lot more tools that are out there. The conversation is less about should I test my JavaScript, my front-end apps, and how should I test it? And there is a lot of conversation about that as well. But it's just great for me to hear that people are focusing a lot more on testing now. Vue has actually been a fairly significant part of that, including testing by default in Vue CLI 2. Having an option for Cypress in Vue CLI 3 is really great, and I'm a big fan of that. So say there's lots of resources out there for testing. Say you're doing testing or you're looking to get into it. So you write tests. So what's the need for test-driven development in particular? Like, what does that process add above and beyond just testing afterwards, writing your code and then writing the tests afterwards? I should define it first, though. Test-driven development is writing your tests before you write the code that passes them. So this is fairly unintuitive the first time you run across it. Like, why would I write a test that I know would always fail? And we're going to talk about some of the benefits for that. Before we jump into that, I'm kind of curious, for those who are willing to raise their hands in the room here, so which of y'all, either on your professional projects or maybe side projects, are writing automated tests of some kind for your Vue app? Okay, who is writing unit tests for it? With Mocha or Jest? Okay, end-to-end tests? Okay, so Nightwatch? Okay, a little bit. Some Cypress? Okay, well, that would be the other end-to-end folks. Maybe the Puppeteer or something else that I haven't gotten a chance to try yet. Cool, okay. So let's talk about why you might want to consider test-driven development, this unintuitive order and process for things. So there's a few reasons that I would give for considering test-driven development, and this is talking in theory here. We're going to see these things hopefully play out in practice in the example coming up. First, I would say that test-driven development gives you a way to get started testing. And when I say get started, what I mean is if you're sitting down, you've got a feature to write, and so it's like, okay, well, what should I write first? Like I could do unit tests, integration tests, end-to-end tests. Like how many of which type should I do? There's all kinds of different views on that, and whether it's a test pyramid or something else. And so it can be a hard question to think through. With test-driven development, at least the approach that we're going to be looking at, it shifts the conversation from what percentage of different types to which ones you write at a certain point in the process. So test-driven development is going to walk us through a step-by-step process where we write an end-to-end test at one point, a unit test at a different point, and it all fits together. So it takes those questions out of the factor. Second, test-driven development helps avoiding testing the implementation. So on my project that I'm working on now, various things about our approach are resulting in me having to write my tests afterwards. And when I do that, I find that oftentimes my tests look a lot like the production implementation of my code, my components of my store modules. Sometimes it literally looks like it was copied and pasted. And so when I look at that, I kind of question whether my tests are adding a whole lot of value. Like anytime I change anything in the code, I'm going to need to change the test as well. It's just a mirror, it's just a copy and paste. So when you test drive your code, you're writing the test first, so you're thinking about the outside of your whole system with end-to-end testing, or of your components with unit testing. So you're thinking about what's coming in and then what's coming back out. And so that can help you to write tests that are different. It separates the time when you're thinking about the interface from the time when you're thinking about the implementation. And so you can get tests that feel like they're providing more value, and they're more likely to allow you to refactor the internals of your code while keeping the interface the same. So that's a benefit as well. The third benefit for TDD that I would say is simple design, and this one's going to take a little explanation. So when you're starting on a project, or maybe when you're starting in your career as a developer, we can tend to start out focusing on functionality. So it's like, well, okay, I don't have a system that is working, and so I want to get to a point where I have a system that is working. So like that would be the main goal, of course, and so we focus on functionality. And now we've got something working, and we ship it, and so now it's like, okay, well, let me move on to the next thing, get the next thing functioning. Now that seems like that would make sense, but over time you can very quickly end up in a situation where you have spaghetti code. Anybody working in some spaghetti code right now, you're willing to admit? Yeah, I mean, yes, for sure, me too. So a spaghetti code is a very suggestive illustration for when you have code that's all mixed together, and it's hard to tell where one thing begins and another thing ends. All the concerns are mixed up. Maybe you have methods in a component that are doing all kinds of business logic and transforming data, as well as doing display in that file. I love single file components, and so there's nothing wrong with that, but those can even exacerbate like if you already have spaghetti code, now you have even more concerns mixed in together. So it's even more important to focus on single responsibility and keeping your code nice and simple with single file components, so you get the benefits of those. So you've got spaghetti code. It makes it slow to work and risky to work on new features. So what can you do? Well, okay, let's really focus. Like let's get on point, and let's focus on design. So like let's think through our app. Let's think through what components we want to set up, what store modules we want to set up. Let's have a single responsibility, like so everything does one thing. Let's really focus on that design and plan out what our app's going to need to do and get it in place. And that can start out really great, but over time that design can deteriorate. So you can get to a point where the original needs of the system, as you saw it, like you were well designed for that, but then you found out before the system was even launched that the needs were slightly different. Or maybe you did launch successfully and that was great, and now it's time to pivot one direction or the other and make changes. And so now you're introducing code that the original design of the system didn't account for, and then gradually more and more over time you end up little bits of spaghetti kind of clumped together and grow hidden inside your application. And nobody likes surprise spaghetti. So your design can deteriorate over time. And so you say, okay, well, we got to figure this out. Like, this is not good enough. Well, let's build our app to be flexible. Like, let's create extension points, places where it's configurable. Like, let's use scope slots for everything. Like, that way we can just change anything out that we need to change out. And I love slope slots. They're really good. But the problem with focusing overly on flexibility is you can end up with over-design. So you can end up in a situation where you're anticipating what are the places where my code is going to need to change, and some of them might not actually need to change. So now you have abstractions and kind of separation of code where it's not actually giving you any benefit, it's just slowing you down as you go. And then some of those abstractions end up being useful, but then there's other places where you didn't anticipate a place that the system needed to flex that it actually does. And so then that spaghetti just sneaks right back in again at that point. So these, like, if these are our options, then we're really sunk. Like, we're really in trouble. Like, we don't want spaghetti code or design deterioration or over design. Like, none of these is going to lead to maintainable software in the long run. So these are the problems that I would say test-driven development is meant to address. It does give you tests that give you good coverage and good confidence in your application, but it also addresses these design problems. And it does so by helping you with these two guidelines that I would suggest coming out of the test-driven development world from years and years of many folks looking into this. First, what I would suggest is build the bare minimum code that you need right now. And by right now, I don't mean like for version 1.0 of your product. I mean for like what is the feature you're working on? What is the Trello card or the Jira card that you're working on? Focus on just that and the bare minimum code that meets those needs. Then make the code easy to change for when you need to do something else. And that something else might be the very next story that you're coming to next. So test-driven development can support you in focusing on these two principles and can really drive you towards it, challenge you towards it to work in smaller steps than you otherwise would have. You could summarize these by saying that we want to have minimal changeable code. That, I think, is the alternative to spaghetti code and the design problems that we discussed there. And that's what we're going to get to see in this example we're going through. But like a lot of conference talks, it is going to be a very small, trivial example. So I'm not going to be able to prove the payoff to you right here in this talk. Instead, what I'd ask you to do is to visualize the payoff. So we're here at a conference, but I would ask you to think about work again. Like, I'm sorry, maybe you don't want to, so you don't have to, but I would encourage you to think about the project you're working on at work right now and to visualize how these principles could apply there, how they could help you on the features that you just worked on or are you working on Monday. So we're going to be taking a specific approach to test-driven development called outside-in testing. And it was first introduced in this book called Growing Object-Oriented Software Guided by Tests by Steve Freeman and Nat Price. So I really recommend it. It talks about these things at even more of a theoretical level, but it gets practical with an extended example as well. So I'll come back with this book and another example, another recommendation at the end of the talk. For now, they have a few diagrams that's going to show us at a big picture level what we're going to be walking through. So most test-driven development has a cycle, a feedback loop that looks a lot like this. First, you write a failing unit test, then you make the test pass, and then you refactor your code. So this is often summarized as red, green, refactor, because red is, in a lot of test runners, you'll get red when a test fails, then you'll get green when the test passes, and then refactor, they couldn't come up with a color, so they just phoned it in. So it's red, green, refactor. So this any TDD approach you'll see will generally take this approach, but outside-in testing adds an additional loop, an additional feedback cycle outside of it. So in this approach, first we write a failing acceptance test, or you might call it end-to-end test. Then, in order to make that pass, we're probably going to need to build out several different things in our application. So at that point, we're going to go into an inner feedback loop, an inner cycle, where we write a unit test and then make it pass and do that several times until the acceptance test is passing. Then we go back through for another feature and write another acceptance test or end-to-end test at that point. So I'm going to be reinforcing these ideas as we go through this specific example, but just think in terms, especially if you're a visual learner, like think in terms of these two nested loops to kind of track with what we're doing as we go through the example. So we are going to be using Cypress for our testing. I mentioned that a little bit earlier. I'm such a big fan of Cypress that people ask me if I work there, and I don't. But Cypress is really great, and I'm so excited that it's included in Vue CLI 3 by default as one of the options. I think that's really great. It's going to help people get a good experience with their testing. I can show you real quick if you haven't gotten a chance to play with Vue CLI 3 yet. It's very easy. You're just going to run vue create to create a new app. And then when you get a list of options, you're going to choose to include end-to-end testing, and then choose Chrome as your option, and it's really great. Incidentally, because the CLI here makes a note about how Cypress is Chrome only and Nightwatch is Selenium based, so to mention a bit about Cypress's architecture, it's designed for modern, rich applications like Vue applications, and so Cypress actually launches a new Chrome instance and it has some hooks into it. So it's able to tell in a lot more detail what's happening with your application for asynchronous requests, animations, and things like that. As a result, though, like it's right now it's Chrome specific. They have a Firefox version very close and working on some other cross-browser stuff. But if you want to run today in all the browsers, you might not be able to use Cypress. But something I told someone earlier is it can be a both-and thing. You know, if there are things that you're afraid of breaking in across browsers, you can write some Nightwatch tests or other WebDriver-based tests for those. But you can use Cypress for test-driven development. Sometimes some of these Selenium-based approaches are good for like QA engineers who are thinking about writing the tests separately, but Cypress is really great for this quick feedback cycle of test-driven development. So it can be a both-and thing. Although in this menu, it's not a both-and thing. You have to pick one or the other. So pick Cypress for the sake of this demonstration. All right, we're going to jump into the example now. So let's say we're writing a chat app. So we type in messages to other people, get messages back. And so we're going to start like the absolute first feature where we say, as a user, I want to be able to send a message. Like that's the story card that we get in Pivotal Tracker or whatever. And so we want to really focus in on this feature and write only the minimal code necessary to implement it. Like I said, we want minimal changeable code. So to start out, the first step we're going to take in outside-in testing is to write a feature test that specifies what the user wants to do. I'm probably going to use the terms feature test, acceptance test, and end-to-end test interchangeably, but I called out feature test here specifically because it kind of describes the test-driven development approach where we're focusing around one specific feature that we're building out, and that's all we're building out. We're not testing a whole flow throughout the entire application or everything on a certain page of the app. We're testing and building out one feature. So we're going to write this feature test, and this is what a feature test looks like in Cypress. If you've used Mocha before, Cypress actually uses Mocha, Chai, and Sign-On under the hood for its features rather than reinventing that wheel. And if you've used Jest, then a lot of what you'll see looks very familiar. So we're just going to create a describe block here where we say we're creating a message in the system, and we're going to write it for a test. We say it displays the messages in the list. Another point, incidentally, we're not going to go into all the details of Cypress's API and how it works here. They have great docs and videos, and so you can check that out. I think it'll be straightforward enough that you'll be able to follow along. So for our app, the first thing we want to do, we need to visit the page, and we can actually just say visit / because Cypress integrated with Vue CLI 3 will actually launch the app as well as the test runner, and it knows the root URL, so you can just visit / to visit the root of your app. Then, so what do we want to do? Nothing's been written in this app. This is a bare, empty Vue app at this point. So what would be involved in building out this feature? Well, we would want to type in a message into some kind of text field. We would want to click some kind of button. I suppose we could use the enter button at some point later, but for now, let's just click a button to send that message. And then we can check that the message is cleared out from the text field, and then it displays somewhere else on the page. So you can see the syntax here. We have so cy.visit to visit the page. Then we have cy.get to get an element off of the page. You can use whatever kind of CSS selectors that you like or that you're maybe used to in other kind of testing approaches. But I'm using data test attributes. And this can actually be a really great approach to make sure your tests don't break when styles change or other things change. A data attribute is just an arbitrary attribute you can add to an HTML element. And we'll see how to do that in the component code in a moment. And it just allows you to, here we call it a data test attribute, to give it a test-specific identifier. So no matter what tags change, no matter what classes changed, as long as that data test attribute stayed in the right place, your test should continue passing. And one thing that's extremely frustrating about tests is when they break for design changes or reasons unrelated to your functionality. So that's why I like to reach for data test attributes. So we're going to find that field, and then we just have a type method that we can call to type into it. So that's really nice. Then we can get a save button, also found through a data test attribute, and click on that. And then what we're going to assert, we're going to get that message text element again and confirm, using a Cypress API, confirm that it should have the value of the empty string. Then to make sure that the new message shows up somewhere on the page, we can just use cy.contains. And that way we don't need to look at any particular element, we just want to know that somewhere on the page this new message is showing up. So this is our feature test, and we want to laser focus in on just building the minimum that's going to satisfy this test. So to do that, next we're going to run the test and watch it fail. So this is part of that red-green refactor loop where we want to confirm that if it's not actually failing, then we've tested wrong because we haven't actually built anything yet. So we can run the test, and this is a screenshot of the Cypress test runner. So it actually opens up a Chrome instance and runs the test runner on the left-hand side, and it's going to step through the tests. Again, the font size may be a little small for you, so feel free to scoot up closer to the front if you like. But so the test runner will actually show that it visited the URL, and then it attempted to get the message text element, and we get the error, expected to find the element message text, but never found it. On the right-hand side, we can see, well, you see an empty white rectangle, so you can't see that it's our application, but believe me that it's our application, and we'll see some actual functionality later. You can see sort of a virtual address bar at the top to show you what screen or what route you're on. So that's the Cypress test runner, and we now have our red, we have our failing test. The next step in outside-in test-driven development is to write only enough code to fix the current error or test failure. And this can seem unnecessary because it's like, well, no, I know what I need to write. I can go ahead and write it. But by taking this approach, this prevents you from that temptation of, let me go ahead and build out this whole component and let me handle the edge cases. What that really ends up doing is building untested code. And so I have a meetup where we talked a lot about test-driven development. And the way I started saying it was, don't build beyond your tests right now because you want the lack of features to drive you to write another test that's going to force you to build out the feature you need. And now you've got the test and you've got the functionality. You're covered by tests. So we're going to write only enough code to fix the current error. So this is our starting component. It's a completely empty app component. And so we need to fix this error by adding some kind of message text element. And so where do we want to put that? I mean, we could get literally the bare minimum code would be to add an input element into this app component, but at that point we've just thrown component-based architecture out the window and our whole application is going to be an app. And so that's not what we want to do. So there's a principle in outside-in testing called write the code you wish you had. This is a principle you can follow that's going to help guide you towards having a nice architecture and having things broken down simply. So in this case, I kind of wish I had some kind of new message form component. Like the form that has like the text field and the button, that feels kind of like a component to me. That feels great. So let's just go ahead and write that. We'll add a new message form into our template. We're going to import that component from a file that's not yet there and set it up in the components property of the component down below so that we have access to new message form. So now we could rerun the test if we wanted to, but we know for sure that that's going to fail. So we can go ahead and create that component. So in a new message form component we create in a separate file, we can create this and we'll just add an input. It's type text and the data test attribute is message text. So that's the way data attributes work, and it would work that way in any other framework or in plain HTML. You can just add a random attribute to your HTML that starts with the data dash prefix. So that should be enough. This is the minimum, given a component-based architecture, the minimum that should fix the current error in our tests. So now we can go back and see it pass. So now we want to rerun the feature test and confirm that we actually fixed that error and see what the next failure is. So when we rerun our test, we see that Cypress is able to get past the message text point there and is able to type into it. It's kind of zoomed out by default, so you can see there in very microscopic content that a new message is being typed. You can zoom into that if you want to. But we've gotten our next error, which unsurprisingly, Cypress has tried to find the save button and it can't find it. So this is, again, where it feels a little bit weird. Like, I could have typed out the save button, like I knew that was coming. That was pretty obvious. And in a real application, like I might very well, even when I'm doing test-driven development, I might add the input and the save button at the same time. But anytime you're learning a new development discipline or any other kind of discipline, it can be good to kind of go by the book to learn how to take small steps. And then once you've learned how to do that, you can make judgment calls about when it's useful and when it's not. So we're going to take small steps for today. So we need a save button, and that's very easy to add, though. We can just add that button to the template of our new message form. We've added it in, we've added another data test attribute to select it, and we're good to go. So now when we rerun our end-to-end test, we get the next error. We've gotten past the components we need to interact with, and now we're getting an assertion failure. So we expected the input to have the value empty string, but it still has the value new message. That's what we typed in, and so that's being saved there because we haven't told Vue to do anything otherwise. So this is a point where it looks like just another red error on the left-hand side, but it's kind of functionally a different thing. The first couple of tests failed because there was an error. We asked Cypress to do something and it couldn't do it because the required element wasn't there. But now we're asserting something and Cypress is saying, well, I can find the thing you're trying to assert against, and the condition is just not the case. The code is not behaving yet the way we want it to behave. And so this is where the approach to end-to-end testing can kind of change, or to outside-in testing can kind of change. And I would say when you get to a behavioral error, that's the point where you can step in from that outer loop of the acceptance test to the inner loop of a unit test, down to, and specifically a component test in this case, and in a lot of Vue.js development. So component tests keep your code changeable. This is the reason why it can be valuable to do it. Because you could say, well, I could continue just running under the end-to-end test, build it out until this passes, and that should be fine. We haven't needed a component test up until this point, so why should we need it now? So the value of component tests, remember we talked about minimal changeable code. And test-driven development and writing the minimum needed keeps your code minimal, but component tests will help your code to be changeable because the component behavior is specified. So you're saying, for this new message form in particular, here's how it works. And then that way, if we move the new message form around somewhere else on our app, we can be confident it'll continue to work. And if we want to refactor inside the new message form to have it work in a different way, we can be confident that it's still working. Say we take it to start it out with just component state, but we decide to switch to vuex for storing that state instead. Well, we can rerun this component test and make sure that the component is still working. So when we're writing a component test, this is the next step that we should take in outside-in testing. Write just enough component tests to reproduce the current feature test failure. So not everything, don't write out everything possible needed for the component just yet. Let the outside test guide you to the inside test. So here's how we could do that. I should have mentioned that in this case, you might be using Vue test utils for your component testing, and it's really great. It's probably what I would use for production projects. For the sake of this presentation, it's actually possible to use Cypress for component tests as well, and I wanted to use it for this presentation, first of all, so that the API that the test runner is making available is consistent across all the different slides. But there's also something we're going to see in just a moment here that's an interesting parallel that's drawn out when we use Cypress for the component tests as well. So when using Cypress for component tests, there's a library, if you look on the first line, called Cypress Vue unit test. So we import a function called mount view from that. And then in our test, we actually import the new message form component. So we're actually going to be passing it to the unit test library to render it out. So we need the component directly. We're going to describe the new message form, and then in a before each block, we're actually able to pass the result of that mount view call to it. So we take our component new message form, we pass it into mount view, and that's going to mount the component up. And this simple approach works if you don't need to pass it any props. If you need to pass it props, you can add some other options in. But this works for our simple case here. And then when that goes in the before each block, like in other tests you've written in the past, that's just going to run it again before each time we rerun a test. So then I have a nested describe in here that describes the situation we're talking about when clicking the save button here. And then we have an it test here that says it clears the text field. So this is, again, focusing on not anything else that the test would need to do. Like certainly our form is going to need to do more than clear the text field. Like it's not the most useful form in the world, but this is all our tests have driven us to at this point. So we're going to define what we need to do to clear the text field. And so we're actually going to be able to use the same Cypress commands that we used in our end-to-end test. We can get the message text from the data test attribute. We can type into it. We can get the save button and click on it. And interestingly, one nice thing about using Cypress for a component test like this is all of Cypress's power for handling asynchrony works out really well, and you don't need to do anything manual. I think Vue test utils handles that as well, but you're actually running the component really in a browser, and so you're getting a lot of assurances from that way. And then we do the same kind of assertion here where we check that the message text field should have the value of the empty string. So those three lines are literally exactly, I guess the line breaks are a little bit different, but they're literally exactly the same lines that are in the end-to-end test. So this really draws out, like, is this really worth it? Like, do we really need that? This is duplicate test coverage. Do we really need this? And I would just go back to what I said before about the value of component test is that you're checking something slightly different. The end-to-end test covers that the application has a text field you can type in and click on a button and see some results. The component test asserts that it's specifically this component's responsibility. So it's documenting the inputs and the outputs of this component. So, you can take your own approach and try it, but I would encourage kind of trying this outside-in approach and see if it helps with the reusability of your components. So we can run this component test in the same Cypress test runner, and it's going to pull up the new message form test, and it's going to give us the same error. We expect the input to have a value of an empty string, but the value is new message instead. So now that on our inner loop, now that the test is failing, we can make the test green by implementing the fix. Now that we're down at the component test level, we can implement the behavior that we want for the component. And to do this is very easy. Up in our template, we're going to use vmodel to map the input's value to a data element. And then we can have, for the click event for the button, we can tie a save function to that. Then down in the component JavaScript, we can define the input text data field and default it to the empty string, so we still get an empty string to start out. And we can define a save method where all it does right now, so this is where that discipline of those small steps comes in again. It's very unintuitive to have a save method that all it does is the opposite of saving. It just throws out the user's data that they provided. So this is unintuitive, but we're still in the middle of the process. We're going to let the test drive us there to the end. So we're writing the bare minimum needed to pass the test. And then when we rerun it, then it succeeds. This test, clicking the save button clears the text field, passes now. So our inner loop is green. There's not really a whole lot to refactor at this point, so we can jump back up to the acceptance test level and see if we've gotten past the current error and if there's another error next. So another way to say it is when the component test passes, step back up to the feature test to see the next failure. or to see if you've succeeded. I suppose that would be another positive way to say it. But it's not a problem to have a failure because this is part of the TDD process. So back up at the acceptance test level, we run through it, and we can see the assertion in green passing, where we expected the input to have the value of the empty string. So that succeeded. Now we're on to our final assertion. So in some sense, we're kind of 75% done, but in another sense, this is kind of the core of the functionality we need that we're just now getting to. So the assertion says, we expected to find the content new message somewhere on the page, but we never did. So now we can go back down into the component test, because this is another behavior, and we want to specify this functionality as well. But at this point, things are a bit different. In our last test for the component, we wanted to assert exactly the same thing in the component test that was happening in the end-to-end test. But is it the form's responsibility to display new message after it was submitted? Well, if we did that, then the whole application would end up in the new message form component instead. And so that still kind of keeps us away from a component-based architecture. So Ed Yarborough from the Vue core team has a book on Vue testing that's really excellent. It's in the list of links later that I recommend. And he uses this term that I think captures it so great. It's called contract testing. He says, other components can assume the component will fulfill its contractual promise that it will produce the expected output if given the correct input. And so this is a description of the approach and the philosophy you can take when testing components. So it's possible, I mean, in JavaScript, you can do whatever you want. So you can go directly to methods and call them. You can go and set state on the component and then do something and see if the state changes. So you can have your test completely coupled to all the details of the implementation of the component. But then at that point, changing anything is very rigid, and rigidity is one of the things that can be really frustrating for tests. So if you take a contract testing approach, it's going to allow you to change the implementation. So at that point, you're focusing just on the interface of the component, what's coming in terms of props, in terms of data from Vuex, in terms of user interactions, and then what's coming out the other side in terms of DOM stuff being rendered, in terms of emitted actions, in terms or emitted events, or in terms of actions dispatched on Vuex, things like that. So one more principle before we jump into the test here is we want to make one assertion per test in unit tests. This can be a great idea because you can Cypress and most other test runners will really show you all of your individual tests, and they'll show you which ones are passing, which ones are failing. So if you have one assertion per test in your unit test, in your component tests, it can really clearly document how a component is supposed to behave. So that's what we're going to try here. Before we just had all of our whole test in an it block, but now we're going to change it and move the setup into before each. So when we're clicking the save button, the things we want to do before each test are going to be, we're going to want to type in that text and we're going to click the save button. So those commands go up into the before each block, and then down in the it block there where it says it clears the text field, we just have one assertion happening there. And at this point we can add another assertion. So back to that question about what exactly we want to assert. Well, I'm not ready to pull in Vuex just yet in the application. I want to stick with kind of plain Vue component state. And so what I want to do here is I think the form should emit an event that actually sends an event back up to the parent component that says, hey, someone has tried to send a message. They tried to save a message. So we're going to test that out. We're going to specify that. To do this, we can use, look down at the bottom first of the test there. It says that it emits the save event. And here we can have something called a save handler that we're going to set up. And we can just say, expect save handler to have been called with new message. So this is using the sign-on library for test doubling. And so if you've used sign-on directly before, Cypress is using that as well. And so we're just confirming that somehow this thing called the save handler has been called. Okay, so now we got to figure out how to get that set up. Well, so back up inside the describe block at the top there, we declare a variable called save handler. And then in the before each block, we assign the result of sci.spy to it. So Cypress is the Cypress test runner, but sci.spy will actually call the sign-on spy method, and it'll return a spy function that we can use for this. Then we can use Cypress.vue, which is made available by Cypress, as you might imagine from the name, that's making the mounted component available to you. I think it may be wrapping it to kind of provide some other functionality as well. But you can call $on it, and you can assign a handler for an event. So we want to say, okay, when the save event is emitted, we want to call the save handler. And this is what is going to hook it up. So in this setup here, we set up the component to call this spy function when the save event is emitted. And then down in the test, we confirm that it was, in fact, actually called. So when we run the test, we're going to see that Cypress actually runs the entire component, and it confirms that we're still clearing the text field just fine, but the save event is not being emitted. the error message says, expected SPY to have been called with arguments new message, but it was never called. So this makes sense, we haven't implemented it. So it's very simple one line to get it working, just in our save method. Now we do something that actually looks like saving, and that is we're emitting a save event and sending the value input text out with it. So now we're taking our user's precious data and actually doing something with it before we just throw it out. So this is good. So this is gonna get the component test to pass, and now we can step back up to our end-to-end test, back up to that outer loop to see if things are good or if we have another failure to take care of. So now we're actually getting the same error as before. A new message is still not showing up on the screen. And that makes sense because what we implemented in that one component is just part of the process. Before, the new message wasn't showing up on the screen because we were just throwing out the user's input. But now the reason it's not showing up is because although it's being emitted, that emitted event is not being handled. So that's what we can do next. So in our application component, we can handle the save event and send it to the add message method. We can define an add message method, taking an argument, and then we can just set up a new messages array in the component data and save the new message onto it. So now we're storing the data in an array on the component, and now we need to output it. We can go back now to that principle of write the code you wish you had. We could put the list directly there in the app component, but I just would prefer to have as little as possible in my app component, and so I think it would be great for us to have a message list component. So let's just write that. Let's pass it the messages. And let's do the required importing and setup so we can use this message list component. And then we can just define a simple component for the message list. It's just going to simply take in messages as a prop. It's going to render out an unordered list because I have no skills in styling whatsoever, so we're just going to use just semantic markup, and then somebody else's, it's open source, so one of you can come in and style it and make it look beautiful. But for now, we're just focusing on the functionality. Incidentally, this is another case where test-driven development is really nice for me. Because I'm not great at styling, like it's hard for me to think about. And so with TDD, I can focus on the functionality first to get things working, and then I can say, okay, time for my mindset shift to styling, and now I can work on that and change the appearance, knowing that the functionality is still gonna work because it's still covered by test. So that's really useful to me. So just this simple display-only component for message list, and we rerun our end-to-end test, and there in very small content over there, you can see that the new message is being shown on the screen. So our whole feature test is passing. The user is able to type in the message, click send, and it shows up on the screen, and the text field is cleared out. Now, it can be a good idea at this point to go back and run your whole test suite to make sure nothing's broken in the component test. And if you're using Cypress for both, then you can just switch back over there and run them both at the same time. So this is a great point to mention, and just to really emphasize that the focus of this talk has been on testing principles more so than Cypress in particular. And so if you're using vue test utils, then that can be really great. If you're using Nightwatch for end-to-end testing, then that could work as well. These principles can work in that approach as well. It's all about taking this test-driven development philosophy and then trying out different tools and seeing which one gives you that quick, reliable feedback loop to allow you to be motivated to run the test all the time instead of just waiting until all of your code is written before you write a test or run a test. So let's look back at that diagram again and kind of think about it. We wrote that failing acceptance test, that failing feature test that said everything we wanted the user to do. And then as we went through, for some of our simple features, just structural things to get some markup and some components on the screen, we didn't feel the need to unit test those. But then once we got to the point where components had functionality, that's where we stepped into unit test, component test level. And we drove those to get the code changeable so that the component test behavior was really specified so that we can move that component around or refactor it as needed. So we followed the red-green refactor cycle in there repeatedly until we got to the point where the outer loop was passing, the acceptance test was passing. And then at this point, we're done. We are done with this feature. We have laser focus on writing that minimal code, and now we can move on to the next feature. Maybe the next feature would be actually sending that message somewhere instead of just storing it in the browser. So minimal changeable code is the phrase I used before. By sticking, very zealously with this approach of only writing the minimal code necessary to pass the test, we were able to write something that was very minimal, as opposed to getting stuck into what are all the things that our form would be needed to do. Let me write out my whole API architecture and data layer and things like that. We were able to focus on just building one simple thing at a time. So this was a trivial example. Any of you could have probably built this functionality in 5 minutes in Vue. But as I said before, I would encourage you to visualize how this could apply to your application. And I want to ask you to imagine. So imagine when you finish building your feature that is already fully covered by tests. And when I say fully covered, at least in Vue CLI 2, the test coverage runner, I think it counts unit tests when it comes to like percentage of test coverage. So it's not fully covered by unit test, but it is fully covered by either end-to-end test or unit test. We haven't written a line of code unless it was covered by tests and we were driven there by tests. I don't know about you, but as I mentioned on my current project, we are writing tests afterwards for various reasons. But when I work really hard at getting a tricky feature working, and I'm like, great, I'm done. Now I just need to figure out how to test it. Like, that's not a very motivating moment. So just imagine, like, when the feature is working and you're done. Like, it's green and it's good to go. It's a fun place to be. Imagine always having a simple next step. So sometimes when a feature is just really complex and you're not sure how to go about it, like you're staring at a blank screen, or you're like, how could I even start? Well, with TDD, you always have a simple next step. You can write a test for what you needed to do, or you can fix the next test failure. That can be much more approachable when you're feeling overwhelmed. Imagine delivering useful functionality every few hours instead of working for days on features that might not end up used. Earlier in my career, we were much more likely to build out a whole data layer or build out a whole API layer. And all of a sudden we find that, some of it's not actually being used, or we didn't think about the way we needed to do it. We needed to change it all up in anyways. So having something useful to deliver, at least to merge to master, at least to show to QA every couple of hours, if not, actually, maybe you could actually go to production with continuous deployment. But you're making concrete, measurable process instead of working on something and hoping it works out in the end. So if you want to see more about this talk, it'll be online eventually, soon. But in the meantime, you can check out this website of mine. I'm pretty obsessed with test-driven development, so I made a website called LearnTDDin, and there's a Vue page on there. So you'll be able to see this tutorial in article form and follow along to it and have a link to the code repo as well as other frameworks if you work in Rails on the server side or React Native or Ember, this kind of following the same TDD process in any of these. I also have a Twitch stream where I'm streaming about TDD so far. We're doing React for web right now, but as I mentioned, all these principles apply just the same. And so if you guys check it out, you'll see how we're approaching testing components, how we're using Cypress. I think it'd be really useful. And so this is every Friday at 2 p.m. Eastern, and the recordings of the archives are available too for you to check out. To get to books, the Growing Object-Oriented Software Guided by Tests is what I mentioned earlier, and especially if the first part of the talk was interesting or appealing or frustrating to you because I didn't get into enough detail, this book goes into tons of detail about the philosophy of this testing and the kind of approach that it drives your code towards in terms of reusability and small, simple pieces of code. So I highly recommend it. Another great one is actually not a JavaScript book either. It's a Ruby book. It's called Effective Testing with RSpec 3 by Myron Marston and Aaron Dees. But this is a book that I recommend to anybody doing web development, whether you're using Ruby or not. And the reason why is it's one of the clearest, most concrete books that I've seen on outside-in testing for web development. It has a ton of great information itself, as well as just thoughts on the trade-offs of different ways to do your tests and why to break them down one way or the other. It also has links to just about every great conference talk or podcast or article that I've seen on tricky subjects in testing that's been really valuable. So I highly recommend checking it out. Again, I work at Big Nerd Ranch, and so if this seems like good quality code that it would lead you to and you need some consulting, we'd love to work with your team on that. We also do training, and so if you'd like to get kind of more training in TDD or in vue.js, we'd love to help you with that. So I want to say thanks so much for letting me come and talk. I've really enjoyed it. You can hit me up on Twitter, check out that link, and I'm going to I guess we'll probably stop the recording, and anyone's definitely free to go, but anybody that wants to hang out to kind of discuss and ask questions, we can definitely do that. So thanks y'all for coming. I hope it was helpful. This might make a pop if I'll keep this on in case folks in the back are asking questions. So anyone is definitely free to go, but does anybody have questions or comments or their own testing experiences to share? Mark?
So I sort of have one. In the situation where you're using Cypress for both the unit tests and there's some duplication there, is it feasible to sort of guess or know what's going to be duplicated and just kind of keep that somewhere else and support it both places, something like that?
That's a good point. Yeah, I haven't. A lot of the apps I've built have been not so complex that I felt the need for that. You could consider doing that. Yeah, I think I'd probably need to run into that in a real project to see. I can share a caution. So this is something you could keep an eye out for. I know there's a pattern called page objects where you kind of define an object that says conceptually on this chat message page. Here's a method to send a message, and here's a method to scroll up or to change a filter or change the sort or something. And we're using page objects on my client project right now, but I'm experiencing some of the pain that people have said for that, where it's like you're multiple levels removed from what's actually happening in the UI. And so I think that would just be the thing to, I'm not saying don't separate those things out, but I would just encourage you to keep a watch out for that. Like, is it harder for me to understand, do I have to look at 2 or 3 or 4 files to understand what's really happening in my tests? The other thing, one sense in which it wouldn't feel as much like duplication is when you have more complex components and unit tests, it's a great idea to just cover not just the main paths, like maybe like the happy path and one error path at the end-to-end test level. And then like more edge cases you might handle just at the component level. And so at that point, like, yeah, there's one little bit that's duplicated, but a lot of other stuff in the component test that doesn't show up in the feature test at all, just from a test speed standpoint. Yeah. Cool. Other questions? Go ahead.
What about the side data implements? So is that just for Cypress? Talk more about that.
Yeah, let me go back and make sure I've got the right thing on the screen. Let me just zoom it out. Oh, I am not plugged into power. That's interesting. Let's see how long we have. All right. Oh, that's awesome. The data test attributes there? Yeah, so the idea, to say this another way, when you want to, it's not Cypress specific. Oops, it's not showing up, sorry. I thought I was presenting still. There we go. So cy.get is a Cypress method to just get some kind of element in the page. And you can use any CSS selector you want. So it could be an ID on an element, it could be a class, or like a data test. It could be a tag, like give me the H1, or a data test attribute. So here, any of those would work just fine with Cypress, just as well or unwell as other test frameworks. But since I was going to write something here, I decided to go ahead with the data test attribute. So that's just, the data prefixed attribute are just supported by HTML, so you can just add those in anywhere. The idea is if your classes might change for styling purposes, and I guess in Vue you're less likely to use IDs than in like older JavaScript frameworks, but like if you have IDs for something else, the data test attribute should only need to change for test purposes. So you're not going to have a design step where you're changing things around and then your tests break. Did that answer your question? Cool. Yep. What else? Questions, comments?
How fast is build?
It's pretty fast. It's so blazing, yes. Thank you for bringing that back. Yes. Do you want an actual answer too, though, or no? Okay, cool. So Cypress, because Cypress launches the browser, I haven't dug into the internals of it, but because Cypress launches the Chrome browser, it actually has hooks into understanding what's happening in your event loop. And so whereas in other frameworks you might need to put in a wait command, to wait for 5 seconds, and then so it's going to wait for 5 seconds whether or not things are ready. Cypress knows when the queue has settled, when there's no other remaining promises or AJAX requests or anything like that. So like if I was running this live and I could actually pull it up and running it live, when something's failing, it'll run for up to 5 seconds just to give it time. And it was like, hey, in 5 seconds, this thing didn't show up. But when it does show up, it catches it right away. I think it checks every 10 milliseconds. So it's actually able to tell, so that's what makes it faster. You can have, those waits are not going to artificially extend the length of your test time.
What it's not supposed to,
Yeah.
right? You're not.
With sliding this test, one thing that I noticed a lot is that sometimes there are cases where like no one knows why, but this test sometimes fails.
Yeah.
Have you encountered that with Cypress, or have you had a better experience with that?
I haven't yet, but for not, I mean, Cypress is great. This is not specifically for their credit. I haven't gotten a chance to use Cypress on like a production full-time work system yet. So have you gotten to use Cypress for full-time, and how has your experience been like?
Oh, so much better.
Yeah?
It's never just like, well, we'll run it again. Maybe it's not actually broken. Like, you can actually trust your tests. Like the one time I had an experience where there was a test that was failing. It's because it was my fault. Which is as it should be.
Yeah. And this is great. Like, as much as I'm like totally sold on testing, like when I get like unreliable intermittent tests. I mean, again, on this client project, like we are using not Cypress, I'll say it that way, and we like our end-to-end tests are sometimes flaky, and so you just get to the point where you're like, well, just rerun it. Like I knew a specific error where it's like when this error comes up, I know that it's just flaky and just run it again. I mean, we had a command to send to GitHub that said it said if you typed in "test this please" in a comment, it would just rerun the test. And so it's like, but you just get to the point where you're just so, even for me who's like totally sold on testing, you just get discouraged about writing end-to-end tests. You're just like, it's only ever pain, it's never benefit.
Or if you tests fail, you say like, well, let's just push the question anyway.
Yeah.
It's usually not.
It's not the place you want to be. But and again, end-to-end testing is hard, and so that's why I'm so excited that Cypress and a few other new testing tools are coming along trying to address those problems by being architected to handle rich apps like Vue apps. So that's great to hear like some commercial experience that it goes as well as the Cypress folks say. So. Other questions, feedback, things about your test experience you want to share? Cool. I'm going to turn off the microphone then. Thank you guys again so much. Appreciate it.